Hello, and welcome back to the JNCIS Security Video Training Series. In this section, we are going to be discussing Junos security policies. So let's get started. Security policies are used to control traffic flows from a specific source or sources to a specific destination or destinations using specific services. If a packet matches a policy, that policy's action is performed on that packet. Basically, a security policy is a set of statements that controls traffic from a specific source to a specific destination using a specific service. Network security policies are highly valuable for secure network functionality. Network security policies outline all network resources within a business and the required security level for each resource. The Junos operating system provides a set of tools to implement a network security policy within your organization. Security policies enforce a set of rules for transit traffic, identifying which traffic can pass through the firewall and the actions taken on the traffic as it passes through the firewall. Host inbound traffic may or may not be affected by a policy. If the traffic is destined for an interface on the device that isn't the ingress interface, it is matched against a policy first. If the policy allows it, it is then matched against the destination interface's host inbound traffic settings for final approval. This graphic shows packet flow through the flow module of a Junos security platform. When the device examines the first packet of a flow, based on incoming and outgoing zones, it determines the corresponding security policy, and it performs a security policy lookup. The system checks the packet against defined policies to determine how to treat the packet. Transit traffic examination. The Junos OS security platforms always examine transit traffic by using security policies. As illustrated in this graphic, should no match exist in the security policy, the default security policy applies to the packet. We highlight the default security policy in a subsequent section. Host inbound traffic examination. If the destination of the traffic is the device's incoming interface, security policies are not applicable. The only examination that takes place is the list of services and protocols allowed into that interface using the host inbound traffic statement within a zone definition. The Junos OS examines security policies if the traffic destination is any interface other than the incoming interface. This process is true regardless of whether the incoming interface and the destination interface are in the same zone, or intra-zone traffic, or in different zones, or inter-zone traffic. This flowchart here illustrates the order of packet examination. When the device receives traffic destined to itself, it first examines whether the destination of the traffic is the incoming interface. If it is, it skips the policy examination altogether. Otherwise, the corresponding security policies evaluate the traffic. If no policy match exists for the traffic, the default policy action applies. By default, the Junos OS denies all traffic through the SRX device. In fact, an implicit default security policy exists that denies all packets. You can change the behavior by configuring a standard security policy that permits certain types of traffic, or by configuring the default policy to permit all traffic, as shown here. Factory default security policies. The factory default template configuration file in Branch Security Platforms has 3 pre-configured security policies. Several implied or default security policies exist in the factory default configuration. An implied, a deny all policy, a trust-to-trust policy that permits all traffic, a trust-to-untrust policy that permits all traffic, and an untrust-to-trust policy that denies all traffic. Policies are matched in the order that they appear in the configuration. New policies are added at the end of the list. Policies can be reordered at will, and the last policy is always the default deny policy. Application level gateways, or ALGs, are processes that associate multiple connections from a specific application to the initial session that the application creates. They are protocol specific and apply both in first path and fast path processing. The ALG association is handled by first path, but the processing is done by the fast path. All ALGs must be able to parse out embedded port and address information, create a temporary gateway for the session data exchange, and handle NAT. This allows, for example, an FTP session to create a data connection from the FTP server back to the client, without requiring explicit policies to allow it. ALGs are configured under the Edit Security ALG configuration hierarchy. Most do not need configuration, but you can set trace options and enable or disable them there. They are applied to custom applications under the Edit, Applications, Application, and then the name, if, for example, you have defined an FTP server on a different port. The Show Security Policies from-zone, zone name to zone, the other zone name, policy name, name of the policy, and detail command will show the ALGs are applied to a policy. Policies must be associated with a source and destination zone, and multiple policies can be defined per zone pair. They are tested in the order that they are configured, and the first match is taken. All traffic that passes through the device is checked against policy. Each policy has a user-defined name, matching criteria, source, destination, application, and an action. They can also be used to enforce IDP and UTM policies. Matching criteria can consist of one or more source, destination, and application definitions. Each of the three elements must be in the policy. Address book entries make it easier to specify source and destination addresses. You can use IP4 or IP version 6 addresses or a DNS name. Applications can also be defined if needed. Many are already built in and can be viewed with the command show groups Junos-defaults applications, or the show configuration groups Junos-default applications. Built-in applications can be altered or new ones can be created. Policy actions can permit, deny, or reject. You can also log and count traffic, and add authentication, VPN tunneling, IDP, and UTM to each policy. Authentication forces users to identify themselves before their traffic is allowed, and you can use either pass-through, that's transit, FTP, Telnet, or HTTP only, or web authentication like HTTPS. Policies associated with tunnels will trigger the creation of a tunnel if it doesn't already exist. IDP-related policies enforce attack detection and mitigation policies, and UTM policies on branch service devices allow AV, content filtering, and URL filtering to occur. User role policies allow for additional matching against a user role. Role information is collected either locally on the SRX from an Infranet controller or through an Infranet controller from an authentication server like Active Directory. This can also allow SSO support or single sign-on, but requires a MAG series device as well. Zone-specific policies override global policies and do not reference specific source to destination zones. Global policies allow you to define policies without being restricted to specific zones. They are configured under the Edit, Security, Global, Policy configuration hierarchy, while address books live under Edit, Security, Address-Book, Global. Benefits to using global policies include lower numbers of policies to configure and reduce system resource usage. Control plane events can be logged locally or to a syslog server. Local logs are stored in the /var/log directory and can be seen with the show log and then the log name command. Data plane logs on branch devices can be stored locally in the /var/log or to the syslog server. You can use session-close and session-init options, though only session-close is recommended, since using both can cause high CPU utilization. High-end devices effectively require logging to go to a syslog server, due to the amount of traffic they are expected to handle. Both branch and data center devices will stream to one server only. The policy action count allows statistics to be shown with the show command, which can be used in various forms. Show security policies will show active policies and their statistics, and if detail is added, the count statistics are added. Show security flow session displays active sessions grouped by SPU. Policy execution can be traced by using trace option commands. They can be used without too much impact, but accepted practices are to only have them turned on when they are needed. Policies can be turned on or off via a schedule within some general guidelines. A single policy can only have one scheduler, but a scheduler can have multiple policies associated. Policies without schedulers are always active. A policy scheduler is a method of scheduling a policy execution for a specific duration or set of durations. A policy scheduler is optional. A scheduler supports system time updates either through manual configuration or through Network Time Protocol or NTP by synchronizing itself with the time changes. Policy changes, by default, do not affect active sessions. This is changed via the policy-rematch statement. Once enabled, it will force any policy to change to re-evaluate sessions that are in progress. Policy deletion is an exception, as all sessions that match the policy will be dropped when the policy is deleted. When the policy-rematch flag is disabled, the software inserts a policy, no impact. The software modifies the action field of the policy from permit to either deny or reject. All existing sessions continue, and the software modifies some combination of source address, destination addresses, and application fields. All existing sessions are unchanged. When the policy-rematch flag is enabled, the software inserts a policy, no impact. The software inserts a policy with no impact. The software modifies the action field of a policy from permit to either deny or reject. All existing sessions are dropped, and the software modifies some combination of the source address, destination addresses, and application fields. The Junos OS re-evaluates policy lookup. Okay, so let's review. What are the basic components of a policy? The basic components of a policy are policy name, source zone and destination zone, matching conditions consisting of one or many source addresses or sets, one or many destination addresses or sets, and one or many applications or sets, and actions. What is the default action for every policy set? The default action for every policy set is, of course, to deny all traffic. What is the purpose of a scheduler within a security stanza? The policy scheduler enables the administrator to dynamically activate or deactivate a security policy. How can you reorder policies? Well, you can reorder policies using the Junos insert command. Alright, that's it for this section. Now it's time to take a short quiz and test your knowledge. After the quiz, move on to the next section. Thanks for watching.